I have a few possible wait, I have a few new ideas of how to solve it. I tried earlier, but I think I have a few better ways I want to try first.
Okay, so want to try first on your own?
Yeah, let me just try.
Okay,
And
sure.
then if I
Try.
Sir, can you give me another hint on this one, and maybe I can try finishing this off on my own?
Okay, sure. So let's see. Here, I told you what the most useful idea is.
To make it a smaller problem.
Exactly, a small example. So we want to see all possible values of this because it says they are non-negative integers. So we know this part is at least what's the minimum value of this part?
3.
No, non-negative, not positive.
Okay, I'm sorry. 0.
Exactly. What about this part? The minimum value is
Minimum value has to also be 0.
yes. So this value, for example, let's consider this value is x. X, what's the minimum value of x?
0.
0. So let's check. Can we create x0?
Yes,
Yes.
when A, B, and C are all 0.
Exactly. Now next value we can check is, for example, a b 0, c1. Let's see in this case x, what x is
It's still
equal
gonna be
to.
0. Wait, no,
No.
no, it won't be. It'll be uh, it'll be 1.
Yeah, so it's good. We were able to create one. Now, for example, we can check which ABCs for the
No,
next.
sir, sorry. It'll be 2. It'll be 2.
So if we check this one is 1, this one is 2. Over 2 is
Okay,
1,
that'll be
right?
2. So that's 1. So that's 1. Correct. Yeah.
We can
My
also
mistake.
check this one. They are 0, 0,
Yes.
1, right? So
Yes.
for the next case, it's good to consider what values for ABC.
So A is 0, B is 1, C is 1.
A is 0, B is 1, C is 1.
Okay. Then that's 2. Then it becomes basically 1. Okay, fine. And then that
In this
becomes
case, x
so
is
2
equal to.
to 2.
Are you sure? Let me check.
No, wait, no, it's not. It's not equal to 2. It's going to be equal to x is equal to 0, so it's going to be 1
1
plus.
plus. Yes, it's 2. It's 2.
So okay, yeah, okay, fine. That's
Here, we
2
can
again.
check this one. 1 plus 1 minus 3, 0, 0, 2, right?
Yes.
Okay, what's the next value?
Then where all 3 of them are 1.
All three are 1, then this part is 0. If all of them be equal, then it is 0, right?
Yes.
Okay, so we can check what values.
Okay, so then when A is equal to 0, B is equal to 0, C is equal to 2, the answer is then 8.
Okay, so let's check different cases. If A is 0, B is 0, C is 2, it is 8. So let's check, for example, what happens A if A is 1, B is 1, C is 2, then this is equal to, what's this one equal to? Do you agree it's 1 plus 1 plus 8, 10, 10 minus 6, right? Is 4.
Yeah.
So we were able to create 4, right?
Yes.
By A, B1, C2. Because look, they are near to each other. When they are near to each other, this one will be minimum, right?
Yes, sir.
Okay, can we create 3? So let's check other cases. If A is 1, 0, 1, 2, this case is bad because then this part will be 0 and it will be large, right?
Yes.
But it will be 8 plus 1, 9. So x9 we can create by A0, B1, C2, right?
Yes, sir.
And if we consider A1 to B1, A1, B1, C2 will be x4. Can we create, for example, 5 A1, B2, C2? then it is equal to 8 plus 8, 16, plus 1, 17, 17 minus, so 1 plus 8 plus 8 minus 3 times the product, minus 12. So it's 17 minus 12, 5, right?
Yes, sir.
And A is 1, B is equal to C is equal to 2, right?
Yes.
Okay, so it seems that, okay, we were not able to create 3. Can we create, for example, 6 or 7?
Let's try 6.
If A is 2, B is 2, C is 3, then it's equal to 8 plus 27, right? Minus 3 times 4 times 3, 12 minus 36, right?
Yes, sir.
So what's this one equal to?
It's equal to 51 minus 36 is equal to 15.
No, calculating
Sorry, is equal to 7.
it. Exactly, so we were able to create 7, right? By A2, B2, C3, right? So it seems that this approach is so much good. For example, x plus 1, right?
Yes, sir.
So if A is k, B is k, C is k plus 1, then what's x equal to? Calculate the question mark in terms of k, okay?
So, sir, I'm getting 3k plus 1.
3k plus 1.
Yes, sir.
Okay, so in this case, if you calculate, let's use this formula. It's easier to calculate. It will be, in this case, 1 half times sum of them 3k plus 1 times 0 plus 1 plus 1. So it's 3k plus, right?
Yes, sir.
So we were able to create 3k plus 1. Like this, you should try similarly, for example, how to create, for example, write some numbers and then find some patterns. And for example, see how can you create 3k plus 2, okay? And then, for
Okay,
example, see if you can create 3k, okay? So the
I see.
approach is this. Here, okay, we tried and we created x0, 1, 2. We were not able to create 3, 4, 5, 7, 8, but we were able to create 9, right?
Yes, sir.
0, 1, 2. 0, 1, 2. 0, 1, 2. Then you say it's 3 over 2, and it's 1 plus 4, 5, plus 1, 6. 6 times 3, 18 over 2, 9. So here we guess that we cannot create multiples of 3, but we were able to create 3, to create 9, right?
Yes, sir.
Okay, then for 3k plus 1, for example, like this, we said, okay, k plus 1, right? And we were able to create 3k plus 1. Were you able to create any other number?
I was so I tried to find others, but then I couldn't see exactly like how the problem would progress from there. So I prefer if we could just start from here, and then we could just work around it. Because I was going, I didn't find a good path for how to
Okay, so
go
let's
forward.
do some. Let's consider this one k plus 1, k plus 1. In this case, what's x equal to?
Okay, 3k plus 2.
Okay, so some of them 1 plus 1 plus 0. So we were able to create 3k and 3k plus 2, right?
Yes, sir.
So what numbers are left?
Sorry, can you say it again?
What numbers are left to check?
We can try. We have to try 3k plus. Hold on one second. 3k plus 1, 3k plus 2.
3k.
Yes.
Okay, so probably we can guess that if we can create 3k,
It
it should
it
be
should be
9k.
yes. Yes.
Okay, so pay attention to 9. Try to create 9k, okay?
Okay. So if we use k plus 0, k plus 1, k plus 2, we get 9k plus 9. But you said you wanted 9k. You just wanted 9k, right?
Yes. So what are ABC equal to?
No, so when we use k plus 1, k plus 2, we get 9k plus 9. But
okay, so it's good because you can select, for example, k, you can set k as 0 here. It says all possible values of this ABC are non-negative integers. So we can create from, we know that if ABC equals 0, this one equals 0, right? For 0, we can create with that. And then, okay, so here, x is equal to 1/2 3k plus 3, right? Times 1 plus 1 plus 4. So it's equal to 6. So if we divide, it's 3 9k plus 9. Because k is at least 0, so it's 9 times k plus 1, right? Because k is at least 0, so we can create at least 9. And for 0, we can say ABC equal to 0, right? Okay, so good job. We proved that 9 k's are possible. What numbers are left to check?
Sir, so I understand how we prove that 3k is possible. I understand how we have proved that 9k is possible. My question then is, where are we going with all with these things? So how does this relate back to the original claim?
K plus 1 was possible. 3k plus 2 was possible. 9k possible. So what numbers are left that we should check?
Oh, sorry, 3k plus 3 we should check.
No, 3k plus 3. So look, 3k plus 3, let me tell you. 3k plus 3 is here. 9k is inside. Agreed? 9k, do you agree is inside of this?
Yeah.
I want to only check numbers that are outside of this, numbers that are left. They have what forms?
But then, sir, here's the thing. Every other kind of 3k, for instance, let's say if you have 3k plus 4, we can rewrite that as 3k plus 1 in some way, right? We can rewrite it as that. 3k plus 5 can be rewritten as 3k plus 2. 3k plus 6, let's see.
No, look, 3k, let's see 3k plus 6. 3k plus 6, if k is 0, it's 6. If k is 1, it's 9. So again, you are considering also these numbers, right?
Yeah.
Well, 3k plus 6 means 3k, only with a shift.
Yes.
So we check these, 3k's are left, right? 3k's are left. But you should split 3k to some parts. One part is 9k. Look, when you consider 3k, there are what numbers? 3, 6, 9. For 9, you said, okay, it's okay. Then 12, 15, 18. Again, for 18, you said it's okay. For 0, you said it's okay. Then 21, 24, 27. Again, 27 is okay. So multiples of 9 are okay. These numbers are left, right?
Yes.
What's the form of these numbers? Obviously, it is not 3k plus 3, because 3k plus 3, again, is all of the numbers, right?
Just 3k, right?
No, again, if you say 3k, 3k will be all of the numbers. I want to work on the numbers that are left. These numbers have what form? You can split these numbers to two parts.
I see.
This part and this part. Find forms of each of them.
Then 9k minus 6, 9k minus 3.
9k minus 3, 9, yes, or 9k plus 3, 9k plus 6, right?
Yes.
Or these numbers are the numbers that are multiple of 3 but not multiple of 9, right? We can say this. Agree?
Yes. I see.
Okay.
Yes.
So probably here we should prove it's not possible to create them, right?
Yes.
Okay, so let's copy this part. So now here, let me tell you one approach. We want to prove one good approach is this. Let's check this. We want to say if 3 divides a cubed plus b cubed plus c cubed, not b squared, b cubed plus c cubed minus 3abc, then 9 divides a cubed. Yeah, if you prove this, the problem will be solved. Because we say if it is multiple of 3, then it is multiple of 9. So we cannot create 9k plus 3 and 9k plus 6.
Yes, that's true.
Okay, so try to prove this. Try a bit first on your own.
Okay. Okay, sir. I think I have a way to show it, but I can't say it very mathematically. But maybe you can see if it's correct.
Sure. What's your approach?
So if we go back up to the hint on top over here, so we can rewrite a cube plus b cube. We can rewrite it as a plus b plus c, and then a squared plus b squared plus c squared minus ab ac bc, right?
Yes.
So you said that given if it's divisible by 3, then sorry, given that 3 divides this, therefore 9 must also. So you want me to prove that, right? Given that 9 must also divide it, right?
Yeah.
So since 3 is a prime number, so we can split this into two terms: the a plus b plus c and the a squared b squared c squared minus ab abc bc. Since 3 is a prime number, we say that both of those terms must be divisible by 3.
No. Because 3 is a prime number, you can say 3 divides this or 3 divides this.
Sorry. Yes. So either 3 divides one or 3 divides the other, right? So if 3 divides a plus b plus c, right?
Yes.
Then we know that. So assuming 3 divides a plus b plus c, we can also therefore say that 3 divides a squared plus b squared plus c squared. Just that, right?
We should prove it. So let's try to prove this. Can you tell me a squared plus b squared plus c squared minus ab minus ac minus bc? One term is this, one term is a plus b plus c, right?
Yes, sir.
We want to make these two things more similar, okay? So can you tell me it's a plus b plus c squared minus what?
So minus 2ab minus 2bc minus 2ac.
No. You made a careless mistake. Minus ABAC BC is correct. ABAC BC, but the coefficient is right. Try to figure out the coefficient.
Oh no! Sorry. It's just 1. It's 1.
No,
Actually,
again, you've made a careless mistake. Calculate this part
hold on.
completely. Okay, multiply it by itself, and then find
No.
the
So
coefficient.
it becomes 3 then, because sorry, I was saying that initially if I were to expand it, it becomes 2ab 2bc 2ac. So from there you must subtract 3 from each one.
Yes, good job. Okay, so it's minus 3. Minus. Okay, so
Okay. I see.
want to try the rest on your own?
Yes, I'll try
Okay.
this. Okay, sir. So if 3 divides a plus b plus c, right?
Yes.
Then we know that 3 must also divide a plus b plus c whole squared.
Exactly.
And because the ab plus ac plus bc can be written as x times a plus y times b plus z times c, we can therefore also say that 3 divides that specific
Yes,
term.
because this one is 3 times something. So 3 divides this part, right?
Yes.
Let's consider, for example, x1, x2, okay? So when 3 divides x1, then x1 squared, so 3 divides x2 because of this, right? Because mod 3, it is x, this one. Because it is divides 3 squared, 3 also divides this, so 3 divides x2, right?
Yes.
What about this case? If 3 divides x2, if 3 divides a squared plus b squared plus c squared minus ab minus ac minus bc, what about this case?
Let's see. Because the 3ab plus ac plus bc is already 3 already divides that. Therefore, 3 must also divide a plus b plus c whole squared.
Yes.
So then, therefore, 3 divides a plus b plus c.
Yes, because 3 is prime, 3 divides a. It is not correct for all things. Look, when 3 divides, for example, w squared, you can say 3 divides w. But you cannot say, for example, if 9 divides w squared, then 9 divides w. This is wrong. Agree?
it has to be prime, right?
Yes, because for example, look, in this case, is W is, for example, 6. 9 divides 36. But
Yeah.
9 doesn't divide 6, right?
Okay, yes, I get it.
But for prime numbers, you can conclude it's 3 divides ABC, so that's good. So if 3 divides the product, 3 divides at least one of them. If 3 divides this, 3 divides this one. If 3 divides this, divides this one. So always 3 when 3 divides the product, 3 divides both of them. So 9 divides this part, and we proved the problem complete, right?
Yes.
Okay, good job.